Well, hey, good day. Hey, you know what? This is our last section of notes for this year. Yay! That's something to celebrate. The title of these notes is Magnetism and Electricity, and this is just kind of going to pull both magnetism and electricity together as we discuss electromagnets, and this is a precursor into the lab that we're going to do. So grab your notebooks. Let's get these notes written down and get prepared to do our lab tomorrow. Your essential question for today is, how does a stereo speaker use an electromagnet to produce sound? And hopefully we can investigate this a little bit. All right, again, the title for these notes is Magnetism and Electricity. So whenever you go to turn this in e-backpack, please look for the Magnetism and Electricity notes and lab. All right, anytime electrical current flows through a wire, a magnetic field is produced, and it forms around the wire. All right, so try to picture this. This is a two-dimensional drawing, but this actually occurs in 3 dimensions. All right, so here's the wire right across here where the arrow is, and then these circles represent the magnetic field that forms around the wire. Okay, so think about this. You know, all of the power lines that line the streets, and sometimes like on the country roads where the high tensile power lines are, there's a lot of electrical current flowing through those things. So there's a big magnetic field also around each of those wires. The reason why the really powerful ones from like the wind turbines and stuff like that, or from an electrical power plant, the reason why they're so high up in the air is because there is a large magnetic field around them. And the goal of the power company is to keep us from being exposed to that magnetic field too much so that it's not dangerous. Okay? Now, the strength of a magnetic field is going to depend upon the amount of current flowing in the wire. That's why, again, those really, really high power lines are higher up in the air, because that magnetic field is stronger because there's a much larger current flowing through those wires. Okay, next. On to an electromagnet. In our lab, we are going to make an electromagnet and investigate how many coils produce the stronger magnetism. Okay, so here's what an electromagnet is. It's a temporary magnet made by wrapping a wire coil carrying a current around an iron core, such as a nail. All right? And here's a little picture of this. We see a battery, the current flow going this way. And we've got an iron nail here with several coils going around it. And as the coils go around the nail, it magnetizes the nail. Okay? It's like magnetized by induction because of the induction of the magnetic field around the wires that are surrounding the nail itself. Okay, so the increased strength of the magnetic field occurs by adding more turns to the wire. So if you add more turns to it, it's going to have a stronger magnetic pull, or also increasing the current through the wire. So you can increase how much how much voltage a battery produces, or change out the battery for a higher voltage battery. That'll also give you an increased magnetic field strength. Next here we've got an electric motor. An electric motor is a device that changes electrical energy into mechanical energy. So there's a bunch of different parts to an electrical motor. In a simple electric motor, the magnet rotates between the poles of a permanent magnet. Okay, so here, these would be our permanent magnets, and here called the field magnets. And inside, this is our electromagnet that rotates. Okay, and it's what we see is that as this electricity goes into this, causing it to rotate around, that makes the mechanical energy of the motor to continue to rotate and to turn the axles, or to turn the pistons, or whatever the purpose of the motor is. Okay? Lastly here, we're going to discuss the difference between direct and alternating current. Direct current, DC, is current that flows in only one direction through a wire. An example of current that we would use that is direct is current that's produced by a battery power source. If you have a battery, it's all of the electrical current is going to flow in one direction. Okay? Now, alternating current is exactly what it says. AC, it's alternating current. It's not going in one direction. The current itself reverses direction in the current flow in regular patterns. So it'll kind of go, it'll oscillate back and forth and back and forth. Very similar to what a wave is. If you remember, whenever we were graphing waves, and when we looked at the transverse wave, it would kind of go like this, up and down. The same thing kind of happens with current as it is graphed. It'll kind of oscillate up and down and go in opposite directions. Okay? Examples of using alternating current include plugging a toaster into a wall outlet. Whenever you plug something into a wall, the type of current that you're dealing with is alternating current. And that's why alternating current is so much more dangerous than direct current, is because the ability to get zapped by it is twofold, because the current is changing direction also. And we have this little example of alternating current. It's a water analogy. So let's say we've got this power source right here, and this whole tube is filled with water. What can happen with alternating current is that the water could be flowing this direction, and then in the next second it could be flowing the opposite direction. That's just kind of how alternating current works. It goes back and forth and back and forth. All right, so let's think about that essential question. How does a stereo speaker use an electromagnet to produce sound? Think about that. Well, an electromagnet can be used to turn electrical energy into mechanical energy. What did we learn about sound when we studied sound? Our last unit that we did. Is sound a mechanical wave? You need to go look back at that and try to do your best to answer that question. All right, this is all for today. We will be starting our lab to make our electromagnet tomorrow, and you're going to use the rest of the class time to get caught up. So get these notes done and make sure you answer that question, and we'll see you later.